Hello guys, welcome to my channel. So today we'll be looking at a simple neural network model. So first, let's import all the necessary libraries, Tensorflow, NumPy, and matplotlib to view the images. Second, let's assign the path, one for training CSV and second for evaluation CSV. If you have the dataset but you don't know how to make the dataset CSV for training and evaluation, please take a look at my previous video. I've demonstrated and given a code on how to make the CSV. Second, let's define some functions so that we can reuse them later. Before that, it's always a good idea to standardize all the height and width for all the images. So I've set the height to 256 and the width to 256. To make it more convenient, I've made a reshape dimension list with the height and width. Next, let's define the classes names. In this neural network, I'm going to categorize cats and dogs. So that will be my class names. So we now have three functions. The first one is read and decode. So what this function will do is it will read the path of the image with the reshape dimension. So what this function will do is it will read the file followed by decode the image to 0 to 255, and this line will convert the image from 0 to 255 to 0 to 1. As machine learning is always better to standardize to 0 to 1, and it will return the image with a standard height and width of 256 in this case. Second is decode CSV. This function we'll be using later. The first, it will read the CSV first column followed by the second column. So it will get the file path and the label of the image. Next, we'll use the read and decode to get the output of the image. This will be the standardized image of 256 by 256. Next, we will get the label of the image. So since neural network can't read string, we have to convert it into, or the right word is to encode it into either one-hot encoding or label encoding. In this case, I've chosen label encoding. I will show the difference later. And finally, the third function is called show image. We just have to give the file path. Then we use read and decode to reshape as well as to read the image, and then we can use matplotlib show to view the image. So let's see the difference between one-hot encoding and label encoding. So here, let's say my label is cat. So it's showing 0 because in the class names list, in the first index is cats, which is 0. So if I change to dogs, it will be 1. So this is label encoding. Now let's look at one-hot encoding. So we look at cats again. So we can see that it's true and false. So meaning for cats it's showing true, and for dogs it is showing false. So let's say if it's dogs, it's false and true. So in this case we are using label encoding instead of one-hot encoding. Okay. So let me demonstrate read and decode. So I have a sample image and I'm going to use the function read and decode. So this will reshape the image to 256 by 256 and also scale it from 0 to 255 to 0 to 1. So you can see all the values here, they are from 0 to 1. And now let's view the image. Yeah. So this is an image with a cat. So next, now that we have a CSV, how are we going to pass the path and the label into the CSV? Into the model. So let's take a look at the CSV. So we have two columns, one with the path to the image, and the second column with the label of the image. Okay. So the first row is the header, and the second row is the first image with the label of the image. So here what we are doing is, for the training dataset, we are going to use tf.data text line dataset, and then we are going to give the path to the training CSV. We are going to skip the first row, and then we are going to map decode CSV function from the second row, which means we are going to use this function here, and then we are going to send in as a batch of, let's say, 2. Usually for computer vision, we'll be sending in a batch. In this case, I'm using 2, but you can use 10 as well. So for the evaluation set, it's the same thing. We are going to read each row. We are going to skip the first row since it's the header. We are going to map each row to decode CSV, and then we are going to send in a batch of 1. Okay. Next, this is just an additional step. So let's say we are taking the image and the label from the training dataset. We can reduce it to RGB, and we can see if the images are corrupted or not. So in this case, we can see values here, so it's not corrupted. We can take like the first 10 images from training dataset, and then there are values, so it is not corrupted. Next, let's create a model. We are going to use Keras sequential model. In the first layer, we are going to flatten the values of each image, and then the input shape is 256 by 256 with 3 channel, which is RGB. So let's see the input shape. So here it is 900. It's close to 200,000 input shape. So let's see the input shape. Yeah. So the input shape matches with the first layer input shape. And then we are going to have one hidden layer with 128 neurons with activation function of ReLU. So what's the difference between neural network and deep neural network? If there are more than one hidden layer, it is called deep neural network. If there's just one, it's called neural network. And we are going to have an output layer of 1. Since we are using label encoding, it is just going to give us one output. Okay. Next, let's compile the model. We are going to use Adam optimizer with loss binary cross entropy, and we are going to use logits equal to true. So basically, logits are natural log of the probability. So the range is from -infinity to +infinity. Since we are not using any activation function in the output layer, I'm going to demonstrate how we are going to convert these logits into a probability from 0 to 1. And we're going to look at the matrix of accuracy. So let's train the model. Okay, so now we have trained the model with 10 epochs. So we can see that the accuracy is around 0.49 and the validation accuracy is around 0.5. So since we only have 2 classes, and if the accuracy is around 0.5, that means it is just random guessing the labels. Okay, so next, let's predict an image using the model. So we have a test image here. We are going to use read and decode. It's an image of a dog, and we're also going to reshape it 256 by 256. So before we predict, we have to input. The image input should be the same as how the model was trained on. So here we are going to reshape the image to 256 by 256, and of course the model was trained in batches, so we have to indicate that it is a batch of one image. So let's see the prediction. So here it is a logic value from negative, so it is a negative 0.00531524. So how are we going to convert this into a probability? So since this is a binary classification, we can use sigmoid function to change the value into a probability. So let's see the probability. So the probability is 0.4986. Okay. So since we have 2 classes, we can have a threshold of 0.5. So anything more than 0.5 can be dogs, If it's lesser than 0.5, it will be cats. So let's see what values or what is the predicted class. So we have to change the probability into numpy first. So since this is a tensor, this probability is in tensor, we have to change it into a numpy array first. And then if it's more than 0.5, it will round off the integer. So let's see the class prediction. So we can see that it is predicted at 0. So let's see what is in the 0 index of the class. It's cats. So even though the image is dog, the model is predicting as cats. So the model is not learning well. I hope this is useful. Please like and subscribe. It will be very useful for my channel. I'm aiming to hit to 1,000 subscribers soon. Thank you so much. Any questions, please comment below so that I can address it, since I can learn together with you guys as well. Thank you. Come back again. Bye bye.